Example 2, we want to eliminate the parameter and hence find the Cartesian equations of the following parametric equations. Okay, so let's say I've got x equals to 3 minus t, y is equals to 2t plus 1. So in this case, we need to identify that t is our parameter. Different values of t are going to produce different x values and different y values. Now, if I start with x equals to 3 minus t, it's quite easy to see that t can just be rewritten as 3 minus x. So if t is equal to 3 minus x, then to eliminate t, we'll take this and we'll substitute it into y, right? So therefore, y is equal to 2 times t. Well, instead of t, we've got 3 minus x plus 1. If I expand, that's going to give us 6 minus 2x plus 1, which is equals to 7 minus 2x, right? So that's all we have for part 1. And this is the standard process that we go by in order to eliminate parameters from simple parametric equation. Okay, just solve the two simultaneously by substitution. Now, if we check out part 2, okay, we've got x is equals to 1 plus 2 tan theta and y is equals to 3 sec theta minus 4. So in this case, we need to identify that theta is our parameter. So if I look at the first equation here, right, where x equals to 1 plus 2 tan theta, we know that 2 tan theta is equals to x minus 1. So in other words, tan theta is going to be equals to x minus 1 over 2. If I look at the second equation, right, we can see that 3 sec theta is equals to y plus 4. Or in other words, sec theta is equals to y plus 4 over 3. So if I want to eliminate the theta, okay, from both these equations, I need to think about how tan theta and sec theta are related. And the trick here is to recognize that tan squared theta plus 1 is equals to sec squared theta. So if that's the case, I can say that tan squared theta, that's going to be x minus 1 over 2, square that, plus 1 is equal to sec squared theta, which is equals to y plus 4 over 3, square that. Okay, and you guys can see that the resulting equation no longer contains any theta. So this is the Cartesian equation that we have. Expanding this thing is going to make it look really nasty. I mean, what I will leave my answer as is just x minus 1 squared over 4, right? Plus 1 is equals to y plus 4 squared over 9. Okay, I wouldn't really go much beyond this. Okay, so that's what we have for part 2. Okay, so now moving on to part 3. We've got x equals to cosine theta plus sine theta, and y is equals to cosine theta minus sine theta. So in this case, I see a lot of cosine thetas and sine thetas, okay? And what comes to my mind is that sine squared theta plus cosine squared theta is equals to 1. Now, there are a couple of different ways of approaching this, okay? One way, okay, in my opinion, which is the easier way, is if I start off with x, right? Let's say I square it. If I take x and I square it, in this case, what we're looking at is, of course, cosine squared theta plus 2 times cosine theta times sine theta plus sine squared theta. And of course, we all know that sine squared plus cosine squared is equals to 1. So in other words, x squared in this case is just 1 plus 2 cosine theta times sine theta. Alternatively, if I take y and I square it, okay, I'll be looking at cosine squared theta minus 2 cosine theta sine theta plus sine squared theta. Now, cosine squared theta plus sine squared theta, that's going to be equals to 1. So in other words, y squared is going to be 1 minus 2 cosine theta times sine theta. So if that's the case, if I've got x squared equals to this and y squared is equals to this, I can get rid of the 2 cosine theta sine thetas by adding these two equations together. So if I take equation 1 plus equation 2, right, x squared plus y squared on the left is equals to 1 plus 1, which is equals to 2 on the right, and then the positive 2 cosine theta sine theta plus the negative 2 cosine theta sine theta, these two will cancel off perfectly, and that's going to leave us with a Cartesian equation, x squared plus y squared equals to 2. Okay, and you guys can see obviously here that we don't have any more thetas in it, so that's a job well done. Okay, so this is essentially one way of getting through the problem. Alternatively, a slightly more tedious approach, in my opinion, would be if I take these two equations, right? X equals to cosine theta plus sine theta, y is equals to cosine theta minus sine theta, right? Solve it on the x and y level for cosine theta and sine theta individually. For example, if I add the two equations together, x plus y is 2 cosine theta. If I subtract the two equations, x minus y equals to 2 sine theta. Once I've got cosine theta and sine theta separately, I can connect them together using the fact that sine squared plus cosine squared is equals to 1. So that's actually another approach. But I think that is actually going to be a little bit longer and it's going to be a little bit more tedious. Okay, so that's why I went with this method. But that being said, okay, do recognize that for any particular question, there are usually more than one way of going about it. Okay, so that's part 3. Now, lastly, for part 4, we're looking at x equals to t plus 1 over t, right? T to the power of minus 1 is 1 over t. And I've also got y is equals to t squared plus t to the power of minus 2, which is 1 over t squared. So when I look at this, okay, one of the first things that I should realize is that t squared plus 1 over t squared is kind of related to x squared, isn't it? Because if I start off with x and I square it, okay, just a hunch, but if I do take this and I square it, you guys can see that taking t plus 1 on t inside brackets and squaring it, that's going to give us t squared plus 2 times t times 1 over t, which is plus 2, plus 1 over t squared. Right? And then if that's the case, you guys can see that in this bracket and I square it, I do end up with a t squared plus 1 on t squared term. Okay, so t squared plus 1 over t squared is equals to y. So then I can say that this is just equals to y plus 2. Okay, so that's how we eliminate the parameter t in this particular case, recognizing that x is related to t squared plus 1 over t squared. And I started off by squaring it just to see what it becomes. Okay, and after I expanded it, an opportunity to replace t squared plus 1 over t squared with y arose, and then I took it, replaced it with y, and that's how we ended up with this Cartesian equation. Okay, so this concludes example 2, just showing you guys how to eliminate parameters, okay, given parametric equations to produce the Cartesian equation. Again, this is a very important skill in this topic, especially when we look at locus later in this topic.